So for this problem, to find the equation of a tangent line and a normal line. So for this given at point 0, 0, so first we need to find the derivative. So for derivative of x squared, this is 2x, then plus the derivative of y squared. So take note that for every derivative of y, there must be a y prime. So for this y squared, so this is 2y, then y prime, then minus the derivative of 6x, this is 6, then plus the derivative of 2y. So again, the derivative of y, so this is y prime, then equals 0. Then from this, so since we can reduce, because every terms are divisible by 2, so we need to reduce. So divide by 2, so this becomes x, then plus divide by 2. So this becomes y prime, then minus divide by 2, this is 3, then plus divide by 2. So this is y prime, then equals 0. Then we need to solve for y prime. So all the terms without y prime transpose to the right. So we need to transpose this positive x to the other side and transpose this negative 3 to the other side. So on this side, so only terms with y prime. So we have y and y prime, then plus. So we have this y prime, then equals. So this positive x becomes negative x. And this negative 3 becomes positive 3. Then we need to factor out this y prime. So put this y prime outside. So therefore the remaining, so since we put this y prime outside, so the remaining is y, then plus for this term. So since we put this y prime outside, so the remaining is 1 because there is a numerical 1 for this y prime, then equals negative x plus 3. Then to solve for y prime, so we need to divide both sides by y plus 1, divide by y plus 1. So cancel. So therefore, the first derivative or y prime equals negative x plus 3 then over y plus 1. So this is now the first derivative. Then from this first derivative, so we can find now the slope, and take note that the slope is equal to the first derivative, and the first derivative is negative x plus 3 then over y plus 1. Then to find now the slope, so this is equal. So from this given coordinate, this is x and this is y. So therefore, x is equal to 0 and y is also equal to 0. So substitute now the values to this equation. So this becomes negative 0, then plus 3, then over. So y is also 0, then plus 1, or the slope is equal to 3 over 1. So therefore, the slope is equal to positive 3. And this slope is the slope of a tangent line. So since we have now the slope of the tangent line, so we can find now the equation of the tangent line. So using this slope formula, that y minus y sub 1 then equals the slope times x minus x sub 1. Then substitute now the values. So this time from this given coordinate, so this becomes x sub 1 and this becomes y sub 1. So we have y, then minus y sub 1 is 0, then equals the slope, and the slope of the tangent line is positive 3, then times x minus x sub 1 is 0. So this becomes y equals 3x, and this is now the equation of the tangent line. Then for the equation of normal line, so first we need to find the slope of a normal line. So using this formula, that negative 1 over m, so since m is equal to positive 3, so therefore the slope of the normal line equals negative 1 over, again, m is equal to positive 3. So the slope is negative 1 over 3. Then from this, so we can find now the equation of normal line since we have now the slope. So again, using the slope formula, that y minus y sub 1 then equals m times x minus x sub 1. So we have y then minus y sub 1 is 0, then equals the slope is negative 1 over 3 times x minus, so x sub 1 is also 0. Then from this equation, if contains a fraction, so you can simplify by multiplying this whole equation by this denominator, so times 3, then multiply, so this becomes 3y, then minus, this becomes 0, then equals to this equation, so you can cancel this 3, so this becomes negative 1 times x minus 0. Then to simplify, so this becomes 3y equals, so we have negative x, and this becomes 0. Then divide both sides by 3 to solve for y. So we have y equals negative 1 over 3x. So this is now the equation of the normal line.